See here, in the previous session, we have seen how can we create the circular single linked list. Now, in today's session, I want to talk about how can we create the linear double linked list. Linear double linked list. See here, in the linked list, how many types are there? Two types are there. In the linked list, two types are there. What are those? Single linked list and double linked list. So, in the linked list, so you already know that linked list is a collection of nodes. In this, two types are there. What are those? First one is the single linked list. Second one is double linked list. First one is single linked list. Second one is double linked list. In the single linked list, a node contains two parts only. The single linked list, a node contains how many parts? Two parts only. So what are those two parts? One is data part and another one is address of next node. So it holds data and address of next node. Only two parts will be there. Whereas in the double linked list, a node contains three parts. A node contains three parts. In the double linked list, a node contains three parts. What are those three parts? One data part and two address parts. It maintains address of next node and address of previous node. Address of previous node. Okay. So see here. So in the double linked list, node contains three parts. One is address of, one is data, next address of next node, and address of previous node. So three parts will be there. In the single linked list, node contains two parts. One is data and address of next node. In the double linked list, node contains three parts. One is data and two addresses. It maintains address of next node as well as address of previous node. Okay. In the previous sessions, we discussed that linked list, linear single linked list and double and circular single linked list, linear single linked list and circular single linked list. See here, so in the linear single linked list, in the linear single linked list, last node's next value is null. So this is the first node, this is the last node's next value is null. In the circular single linked list, last node's next is first node. So last node's next is holding first node's address. So that's why it is becoming circular here. So this already you know. Now see about double linked list. Observe. In the double linked list, a node contains how many parts? Three parts. In the double linked list, a node contains three parts. Just a minute. Yes. In the double linked list, a node contains three parts. What are those three parts? Yes. System is slow. Please wait. Okay. See here. So node contains how many parts? Three parts. One is data part. It holds address of next node and address of previous node. So in the linear double linked list, first node's previous value is null because before this no node is there. So no previous node is there. So first node's previous value is null. Last node's next value is null because after this no node is there. So last node's next value is null. Whereas in the circular double linked list, this first node's previous node is last. Last node's next node is first. So this is the last node. In the last node, next we are holding first node's address. So we are making first node as the last's next node. So last's next node is first node, and first previous node is last node. Hence, it is becoming the circular. It is becoming the circular. Okay. Just a minute. Okay. Okay. See here. See, listen. I want to create linear double linked list now. So this is the linear double linked list. I want to create the linear double linked list. I want to create this linear double linked list. Okay. So I'm showing it linear double linked list. I'm showing. So this is the linear double linked list I want to create now. So this is the first node. This is the last node. Okay. So here 10, 20, 30, 40 are the data. So here first node's previous node is null. First node's previous value is null. Okay. So this is the first next node. Okay. So this first is the previous node of this one. So here we are holding previous node address. Here we are holding previous node address. Here we are next node address. Here, here we are holding next node address. Here we are holding previous node address. Here we are holding next node address. Here we are holding previous node address. Okay. So after this last no node is there. So its value should become null. Null. I have to create this linear double linked list now. So what is this one? This one is the linear double linked list. Linear double linked list I want to create. Listen carefully here. So to create the node object, define a class node. Define a class with the name node. Okay, so node contains three parts in the double linked list. So X, I'm taking X property to hold the data. I'm taking next pointer variable to hold the address of next node. I'm taking pointer previous variable to hold address of previous node. So take these two as the node type, X as the int type. So in the X we are holding data. Here we are holding address of next node. The next we are holding address of next node. In the pre variable, in the prev variable, in the previous variable, we are holding address of previous node. So define this class now. Just a minute. Yes. So now define this class. Sorry. Define the class node. Now define another class. Define another class with the name d-linked list. The name d-linked list. In this, take the properties. To hold first node's address, take first property. To hold last node's address, take last property. Okay. To hold temporary node address, take temp property. To access the elements, I'm using one pointer variable here. So these are the properties. Then define the methods. Define one d-linked list constructor. Define d-linked list constructor. Okay. Then just a minute. Then to add the node, define add method. To print the elements, define show method. So this is another class I want to define. So how many classes we have to define now? Two classes. For the single linked list also we defined these two classes like class node and class linked list. Now we are creating two classes, but here extra we are taking previous node. That's it. This one is extra. So we are maintaining next node address as well as previous node address. Then what is the benefit here? What is the benefit of maintaining previous node address? So if we maintain the previous node address, we can access the elements from last to first also. In the linear single linked list, we can access elements from first to last, but we cannot access the elements from last to first. Whereas in the double linked list, we can access the elements from first to last as well as last to first. That is the advantage here, because in the double linked list we are maintaining previous node address also. So from last to first also we can access, because previous node's addresses we are maintaining. Whereas in the linear single linked list it is not possible, because there we are not maintaining previous node's addresses. There we are maintaining next node's addresses. We can access from first to last, but not last to first in the single linked list. In the double linked list, we can access the elements from first to last as well as last to first, because we are maintaining next node's addresses as well as previous node addresses. Okay, that is the advantage here. So here two-way accessing is possible here. Okay, so now what we want to define, we want to define these two classes now. After that, create object for this d-linked list class, add some nodes, add some elements, and print those elements by calling show method. That's it. This is our task. So now we have to define how many classes? Two classes. Listen, observe carefully here. I'm opening developer C++ here. So you already know the concept. I explained fastly. Listen. I'm opening one new empty CPP file. Define a class with the name node. So node contains the three parts in the double linked list. Now we want to create linear double linked list. So to hold the data, take X. To hold the address of next node, take pointer next. To hold the address of previous node, take pointer previous. One class definition is over. Define these properties in the public section. Define these properties in the public section because I want to access them outside of this class. So define them as the public section. Then define another class. I'm giving this class name as D-link list. D-link list is the class name. Define the properties of this class. So what are the properties? Node. Okay. First, last, temp, pointer. Four properties I'm taking. So define them in the private section. So define these properties in the private section. In the public section, define the constructor. So constructor name and class name should be same. So I'm taking D-linked list here. D-linked list. So initially there is no first and there is no last. So write last equals to first equals to null. Means no addresses are there. Null. First value is null. No nodes are there. First value is null. Last is null. So null value will be assigned to the first. First value will be assigned to the last. So last equals to first equals to null. We are writing. Okay. Then to add the node, I want to define a method, add method. So I'm giving method name as add. So which value we want to add, which element we want to add, that value we pass. So I'm assuming that as a v. I'm assuming that as a v. Okay, that v value we are passing. So when we call this add method, we call like this. So if L1 is the object, L1 dot add, we give the value as 10. L1 dot add of 10. We call like this. Okay, I don't want to return any value. So return type is white. So now this 10 value, this 10 value will be passed to the variable v. So now what is the v value? V value is 10 now. So now create a node. So to create the node, create object for node type. So new means memory will be allocated. Here we are creating the object. Here we are creating the object. So now what happens here? One object will be created. So here one object will be created. One object will be created. So this is the object. So in this object, three parts are there. In this object, three parts are there. Okay. So here it holds previous node address. Okay. Then X, then next node address. So this temp node will be created. So what is this node's name? This node's name is temp now. This node's name is temp. Okay. So I want to hold this node's address in the temp. So write temp equals to new node. So one temporary node is created. So here we want to store the value as 10 here. Here we want to store the value 10. Here we want to store the value 10. So temp x equals to v. Right? Temp x equals to v. So write temp x equals to v. Okay. One temporary node is created. Okay. So here now check whether it is the first node or not. Check whether it is a first node or not. So for that, what we write, if first equals to null. Okay. So if first value is null means we are this one is the first node. First value null means this one is the first node. Just a minute. Just a minute. Oh. Okay. Try to understand. Okay. See here. Just a minute. System is slow. Please wait. Yes. Observe here. Observe carefully. So if first value is null, so initially first value is null. So when we create the object, initially what is the first value? First value is null. Okay, when we create the object, initially first value is null, last value is also null. So if first value is null means this one is the first node. So make this temp as the first and make this temp as the last. Now this one is the first node and this one is the last node. Okay. So before this, okay, yes, make this as the uh, so if this is the first node, make this temp next value as the null. So after this, no node is there, and before this also no node is there. Before this also no node is there. Make this value as null. Make this value as null. Okay. So temp next value is null. Temp previous value is also null. Temp next value is null. Temp previous value is also null. So right here. Right here. Temp next equals to temp previous equals to null. So now temp previous value is null, temp next value is also null. Okay, so this node is created. Okay, so now this one is the first node and this one is the last node. So make this temp as the first node. So for that write first equals to temp and make this temp as the last node. Make this temp as the last node. For that we write last equals to. So write last equals to first equals to temp. So now this one is the first node and this one is the last node. This one is the first node and this one is the last node. Okay. Now, if this condition is false, if this condition is false, come that goes to the else block. That goes to the else block. So now what we have to do? Again, we have to create a node. I want to create one more node. So I'm calling like this L1 dot add of 20. Okay, so here add method we are calling. So now what is the v value now? V value is 20 now. Now v value is 20. So this code will get executed. So new node means a new node will be created. New node means a new node will be created here. So like this, a new node will be created. Okay. So now this new node's address will be given to the temp. Now this one is the temp. Okay. Now this one is not a temp. This one is not temp. This one is the temp. So temp x equals to v. What's the v value? 20. So 20 value will be stored in this node. Okay. So make temp next value as null. So to make temp next value as null. Okay. So that comes to else block because first has some address. So temp x equals to v. So first equals to null. This condition will be checked. First has this node's address. First has this node's address means first value is not null. First has this node's address. First has some address. So this condition is false. That comes to else block. In the else block, I am writing temp next equals to null. So after temp no node is there. So write temp next equals to null. Temp next equals to null. Okay. Now listen carefully here. Make now this one is the last node. This one is what? Temp. Make this temp as the last node's next node. Make this temp as the last node's next node. Means we have to establish a link. We have to establish a link like this. Okay. So I want to hold a temp node's address here. So means its value is not null. Now it is holding temp node's address. It is holding temp node's address. It is holding temp node's address. So this temp node's address I want to hold in the last next. I want to make temp as the last next. So this temp address I want to hold in the last next. So what we have to write? Last next equals to temp. Okay, so this link will be established. Okay, so this link will be established now. Similarly, make this last as the temp previous node. Make this as the temp previous node. I want to establish one link like this. So this is a temp previous. So in the temp previous, hold last node's address. Okay. So write temp previous equals to last. Temp previous equals to last. Temp previous equals to last. So this link will be established now. So this link is established. Okay, now make this temp as the last node. Now this one is the not last node, this one is not last node, make this temp as the last node. So to make temp as the last node, write last equals to temp, right? Last equals to temp, that's it. Last equals to temp. So this is the code, this is the code. Okay, that's it. Adding node is over. Just a minute, I'm arranging the code here. Just a minute. Yes. Okay, so this is the code. Now I want to add one more node. I want to add one more node. So to add one more node, what we write? So try to understand. So last node I'm adding. Listen carefully. So same code I'm explaining now. I want to add one more node. So write L1 dot add of 30. Okay, so now add method we are calling. Now what is the v value? What is the v value? V value is 30. Now v value is 30. So temp equals to new node, means one new node will be created here. So here new node will be created. This node has three pods. One is previous, one is x, and another one is next. So temp x equals to v. What is the v value? 30. So 30 value will be stored in the temp x. So here this one is the previous, this one is the x, and this one is the next. Okay, so temp x value is 30. Next it checks whether it is the first node or not. It is not first node, first it has some address, so it comes to the else spot. So temp next equals to null. So this node's address is in the temp. Now is the temp node is created. So temp x value is v, it's 30. So temp next value is what now? Null. So temp next value is null. So last next equals to temp. So this is the last. So now this will become the last next. Last next. Okay. So last next. So temp is becoming last next. So this link will be established. So next temp previous equals to last. So temp previous here it holds last node's address. Means this link will be established now. So now last is holding temp node address. So temp for this last node, temp is the next node. For this temp, last is the previous node. So for that we are writing this code. So last next equals to temp means temp is becoming last node's next node. Temp previous equals to last means this last is becoming temp's previous node. So links are established. Now make temp as the last. So now this one is not last. If this one is temp means this one is not temp. This one is not last. Okay, now this one is the last. Now this one is the last. That's it. So first node name is first. Last node name is last. Link list is created. Hence we can create the link list. I hope you understood. I'm clearing all ranks here. Okay. So this is the code for adding a node. I want to print the elements now. I want to print the linked list elements. So to print the linked list elements, I want to define a method, show method. Show method. I don't want to return any value here. I don't want to return any value. So write return type as white. Observe. Observe carefully. So you already know how can we print the elements in the linear single linked list we discussed. Now we want to print double linked list elements. So assume this node as the pointer. Assume first node as the pointer. Assume first node as the pointer. So if first node is the pointer, so this node will become pointer next. So next time make this pointer next as the pointer. Okay. Next time make this pointer next as the pointer. Now this is the pointer next. So make next as the pointer. Next time make this pointer next as the pointer. So like this we go and we access the elements. Okay, so to access the elements, first time we are assuming first as the pointer. So to access the element, we write pointer x here. Pointer x. Pointer x means 10 will be printed. So if this is pointer, this is pointer next. Next time make pointer next as a pointer, then again access this x. Pointer x. 20 will be accessed. So if this is pointer, this is the pointer next. Pointer next make as the pointer. If this is pointer, to access this 30, write pointer x. Again, we are writing pointer x. So if this is pointer next, this is the point. If this is pointer, this is what? Pointer next. Make pointer next as the pointer. Okay. So here, to access the element, we write pointer x. So now pointer next make as the pointer. What is the pointer next value? Null now. After this, no node is there. Pointer next value is null. So now pointer value will become null. If pointer value is null, stop. If pointer value is not null, print the values. So for that, I'm writing here for loop. I'm writing. So initially pointer value is what? First node we are assuming as pointer. Okay. So make pointer next as the pointer. So pointer equals to, so to print the element, what we write here? C out insertion operator pointer x. To get 5 spaces, write slash t. Okay. So next time make pointer next as a pointer. So for that, write pointer equals to pointer next. So now pointer next is becoming the pointer. Pointer x means second element will be printed. Next pointer next will become the pointer means pointer x means third element will be printed. So we have to do this process till pointer value is, when pointer value is not null, we have to execute this code. When pointer value is null, we have to stop it. So here we are accessing from first to last. Okay. Now define the main method. Define the main function here. Int main, starting point of main, ending point of main. Create object for delinked list class. So for the delinked list class, I'm creating the object to add the elements called add method. So L1 dot add of 10. Like this, I want to add 3 more nodes. Okay. So I'm copying it and I'm pasting here. So here this one is 20, this one is 30, and this one is 40. I want to print all elements. So to print all elements, write L1 dot show. L1 dot show. That's it. So now this null defined in IO stream header file. So we must write hash include IO stream. Okay, then cout is declared in the std namespace. So write using namespace std. Now save it. Save this program. I'm saving in our folder. Our folder name is cppds I'm giving file name as d linked list, d-linked-list.cpp. Observe here. Now I'm running the program. I'm pressing F11. Okay, no errors, no warnings are there. I'm pressing F11. Observe, that is giving the output. One error. Okay, here after null, I have written semicolon. Here write the colon. I have to. We have to write the semicolon. I have written colon there. Okay, I'm pressing F11. Observe. Okay, save it. Save it and press F11. Observe the output. See, that is printing 10, 20, 30, 40. So from first to last, we are accessing. I already told that the advantage with the double linked list is, okay, we can access the element from last to first also. We can access the elements from last to first also. Okay, from first to last, we are accessing. Now I want to access the elements from last to first. So what I'm doing is assume this last as a pointer now. Okay, I'm clearing it for our understanding purpose. I'm clearing all these things. Okay, assume last one as the pointer. Assume last one as the pointer. Okay, so for that, what we write? Pointer equals to last. Pointer equals to last. So to print the element, we write cout insertion operator pointer x. Means last element will be printed. Now last element will be printed. Okay, so if this is the pointer, observe. If this is the pointer, this one is what? Pointer previous. This is pointer means this is what? Pointer previous. Okay, so now this one is the pointer previous. This one is the pointer previous. So make this pointer previous as the pointer. Make this pointer previous as the pointer. So for that, here, which code we have to write? We have to write pointer equals to pointer previous. Pointer equals to pointer previous we are writing. Okay, so pointer previous will become the pointer. So again execute this code. Pointer x, previous element 30 will be printed. So till where we have to do this process? Okay, so next time this is the pointer previous, this pointer previous will become the pointer. Next time this is the pointer previous, this pointer previous will become the pointer. Next time pointer previous value is null, so null value will become the pointer. So if pointer value is not null, we have to execute the code. So here write the condition as pointer not equals to null. So this is the for loop code. So this code we are writing in the for loop. In the for loop we are writing this code. So this code we have to write to access the elements from last to first. To access the elements from last to first, this is the code. This is the code. Okay. So this code I'm writing in the developer C++. Okay, less time is there. Listen carefully here. Just a minute. Developer C++. I'm opening. Okay, maybe that was closed. Okay, I'm opening the file. File. So just now we have written this program. So this is the program. I'm clearing all these drags. Okay, observe. Okay, now I want to access the elements from last to first. So to access the elements from last to first, what we write? Assume last one as the pointer. So write pointer equals to last. Okay, so to print the element, write C out insertion operator pointer x. So last element will be printed first. After that, make pointer previous as the pointer. So to make pointer previous as the pointer, so write pointer equals to pointer previous. So we are doing this process. We are doing this process till pointer value not null, that has to execute the code. If pointer value is not null, that has to print the value. If pointer value is null, stop. So here we are accessing elements from last to first. So here I want to change the line between these two. So I want to change two lines. Here I'm writing /n/n. Save it. So finally I'm running it. Observe F11. I printed. See here 10 to 40. Here elements are printed from 40 to 10. So we can access the elements from first to last to first in the double linked list, because we are maintaining previous nodes addresses also. We are maintaining previous nodes addresses also here. We are maintaining previous nodes addresses also. So that's why we can access the elements from first to last or last to first. Okay. So just now we have written this program. So this program's output is that is printing. We are creating the double linked list and we are printing elements from first to last and last to first. Okay. Now I'm stopping the session here. So this is about creating linear double linked list. In the next session, I explain about how can we insert the node in this double linked list. Okay. Now I'm stopping the session.